In this question, it has been given that a farmer has 80 hectares of farm available for planting rubber tree and oil palm tree, and he must grow at least 10 hectares of rubber tree and 20 hectares of oil palm tree to meet the demand. And he prefers to plant more oil palm tree than rubber tree. But he cannot cultivate maximum. He's been limited by the workforce and equipment, so he can cultivate maximum 3 times the quantity of oil palm tree to that of rubber tree. And there is also a constraint of the government policy, which is planting rubber plant tree cannot exceed the oil palm tree by 40 hectares. So we have to have a maximization problem to find out the maximum profit such that the profit per hectare of planting the rubber tree is RM1320 and profit per hectare for planting oil palm tree is RM1440. Exactly the problem is? The problem is a farmer has 80 hectares of farming land and he must grow at least 10 hectares of rubber tree and 20 hectares of oil palm tree. Further to that, there are two constraints. One is about the workforce and the equipment. He can cultivate maximum 3 times the quantity of the oil palm tree to that of rubber tree. The second constraint is of the government policy. Rubber tree cannot exceed oil palm tree by 40 hectares. This question is about maximization of profit. The profit per hectare for planting rubber tree is RM 1320 and the profit for oil palm tree per hectare is RM 1440. So we have to write the maximization equation and solve the question. Now let us try to formulate the constraint equation and the objective function. The total farmland available to the farmer is 80 hectares. He has to grow 10 hectares of rubber tree and 20 hectares of oil palm tree minimum. So let us say that X hectares of rubber tree is being grown by the farmer and Y hectares of oil palm tree is grown by the farmer. Therefore, the first constraint equation will be X plus Y should be less than equal to 80. Since it has been given that at least 10 hectares of rubber tree should be grown, the second constraint equation will be X should be greater than or equal to 10. And the third constraint equation is given as 20 hectares of oil palm tree minimum he has to grow. So Y should be greater than or equal to 20. Now his workforce and equipment are not sufficient. So maximum he can cultivate 3 times the oil palm tree to that of rubber tree. So therefore the next constraint equation will be X should be less than equal to 3Y. There is again a constraint of government policy. The government policy says that you cannot exceed oil palm tree by 40 hectares. The constraint equation for that will be X minus Y should be less than equal to 40. Now these are the constraint equation. The objective function should be Z. Z is for the maximization will be equal to 1320 multiplied by X plus 1440 multiplied by Y. That is the profit per hectare for rubber tree is RM1320 and number of rubber tree he plants is X and profit per hectare of oil palm tree is RM1440. Once we have decided on the constraint equation and the objective function, let us try to see the constraint equation one by one. The first constraint equation, x plus y should be less than equal to 80. So this is the first constraint equation. Next constraint equation is the number of rubber plants should be greater than or equal to 10, that is x should be greater than or equal to 10. The oil palm tree should be greater than or equal to 20, that is y should be greater than or equal to 20. Hence we can see that these three constraint equations gives us a triangle. The government policy says that x minus y should be less than equal to 40. So according to the government policy, the constraint equation is x minus y should be less than equal to 40. So anything above this purple part will be coming into the picture. Lastly, the number of oil palm trees which he can put should be equal to 3 times the rubber plants, that is y should be less than equal to 3x. So this is the constraint parts. So if you can see over here, the points which comes into picture is this particular one point, and this is another extremum point. So these are the points which are coming extremum points. This is another extremum point. So I'm just marking all the extremum points which is possible in this particular case. So 1, 2, 3, 4 are the given points. The area should be within this region. So the feasibility region is between these given points 10, 20, 10, 30, 20, 60 and 60, 20. We will try to put it in the uh, maximization table and try to find out the feasibility report. Now, after plotting the graph, we get four extremum points, viz 10, 20, 10, 30, 20, 60, and 60, 20. We put it in the objective function and evaluate the value of z. So in the right hand side column, we see that the maximum value of z is equal to 112800. So the maximum profit is possible only when he plants 20 hectares of rubber tree and 6